All right, welcome to chemistry. Today we're looking at week 5B lesson, and the success criteria is that I can write and balance the chemical equation when given the name of each compound in the reaction. So we are not going to be balancing equations in this, but we are going to be writing them. And so you need to make sure you read the following notes. You should be familiar with this graphic by now. This tells you all the charges of the ions that are on the periodic table, monatomic ions, meaning one atom ions. Each of these are made up of one ion or one atom. And then we have our common type 2 cations, which are cations that have more than one possible charge. So their charge is written in the name. And so we call this type 2. And we can see those right in this area with titanium, chromium, manganese, iron, cobalt. Each of those have more than one charge. And so the charge is listed in the name. Then we also have our polyatomic ion sheet. You should be familiar with these. Most of these have an ending in ate or ite, but there's some that don't. One that we're going to be dealing with today is ammonium, NH4. It's the only polyatomic that has a positive charge. It's the only polyatomic cation. All right. And you might want to read this. The most important things here is that if you have a compound with more than one polyatomic ion, that you need to put a parentheses around that to indicate the number of polyatomic ions that you have there. If you don't use a polyatomic, that is definitely going to cause you to have a wrong answer. You can use one when it's not needed and you will be okay, but if you don't use one when it is needed, it is a problem. Okay, just like any ionic compound, the overall charge for the ionic compound must be neutral or zero. So that means when you sum the charges or you add up the charges from the cations and the anions, you should add up to equal zero. And we've seen this graphic before. You should be familiar with molecules. Molecules use prefixes, and you should be able to identify a molecule by the prefix. You should also be familiar with your diatomic molecules, and they are listed here. There are 7 of those. So be familiar if you get a name like oxygen and you're not sure if it's a diatomic, go back here and see if it's a diatomic. If you see that it is listed as a diatomic, you must put a 2 in the formula, because di means two atom molecules. These are made up of 2 atoms. So that's why each of these have a 2. Okay, and then you should be familiar with reactants and products and where they are located in an equation. So today we are going to just look at writing the formulas, and then I'm going to ask you to put those in an equation. So I'm going over a few examples of some formulas and how to show your work on this. So the first example is to write the formula for ammonium sulfide. And right now this says do not do this problem. That is not true. I want you to do this problem with the video. And actually, as I'm doing this live in class, I want you to do this with me. So if you missed class, we did this in class together. I'm erasing this do not do this problem after this video. So you're going to go, the first thing you're going to look at for this name is write the formula for ammonium sulfide. And you're going to ask yourself, is this an ionic compound, a molecular compound, a diatomic, or an element? So you have to ask yourself those things. And so if you look at this name, you do not see any prefixes. Also, if you look at this name, you can tell that it's made up of more than one thing, so which that eliminates diatomic and element. So it does not have prefixes, so that eliminates molecular. So this is ionic. So what you're going to do is you're going to circle ionic, and that will take care of that. Now, if it's ionic, you have to show the charges so that the sum of the charges equals 0. Ammonium sulfide. So let's go find ammonium. And I told you earlier that ammonium was the only polyatomic cation that we have listed, meaning it's the only polyatomic with a positive charge. And it's right here. Ammonium ion is NH4, and it has a 1+ charge. So we're going to make sure we put that in our show your work. And again, you're doing this too. This is worth some points. So you're going to put in NH. Of course, you have to go outside of that subscript anything and move that to where it is subscripted. So there's NH4, and then same thing with the charges, right? We have to superscript the charge and it's going to be a +1. And we'll move that to the top right corner, and we can even change the size of that. So we have ammonium, the ammonium ion. Now we need to find sulfide. And sulfide is sulfur as an ion, right? And so we just go to our periodic table, we see sulfur, and that sulfide is an ion that's -2 charge. And so we go back to number 10, we go to show your work, and we're going to type in sulfur, and then we're going to show that that has a -2 charge. And that is very easy. Move that in there. And now, if you see that the sum of the charges equals 0, you have nothing to do but write your formula with one of those each. But unfortunately, we have 1 ammonium and 2 sulfide. So we have to address this. Anytime you have a polyatomic, just like we discussed earlier, you're going to want to add a parentheses, because you're never wrong with adding a parentheses. So we're going to add a parentheses, and we'll discuss this a little more later on. We add the parentheses, and then we can show the cross technique. And so we'll move a line there, and we'll move a line there, and we just simply type in our subscripts. So this is going to be a 2, this is going to be a 1. And so let's move those to the appropriate place. Boop, 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 boop. There we go. And let's move this one to the appropriate place. Maybe that's a little too small. Okay, so now we can see that 2 times 1 is +2, and 1 times -2 is -2. And so we have the sum of the charges equals 0. So that condition occurs when we have 2 ammonium ions. So we're typing NH, we're going to go to the calculator, subscript the 4, outside of the parentheses, we're going to subscript a 2. And that matches our picture. And then you're just going to type in S. All right, and make sure that if the element is capitalized on the periodic table, it's capitalized in your formula as well. All right, that's causing some people to get those incorrect. So that's all you would have to do for that problem. The next one says, write the formula for silicon dioxide. So for silicon dioxide, you should recognize that it has a prefix. All right, and if it has a prefix, then it is a molecule. And we can see here, the word di means 2. If you have only one of something, or if you don't have a prefix on the first name of a molecule, then there's only one of that. So what you're going to do is you're going to type in your symbol, Si and O. Underneath Si, I just want you to write no prefix. And what does no prefix mean? It means there's only one of those. And that's only if you have a molecule, all right? Because others don't have prefixes at all. But we see the word dioxide, so we know this is a molecule. So what does di mean? Di means 2. So di equals 2. So you should not show any charges here. If you do, you will be marked incorrect. So you have 1 silicone, 2 oxygen, and that's what that means. Si, and then O, and then subscript 2. And that's all you got there. That one is done. And then the last one, it says write the formula for nitrogen. So you should recognize this is just, one thing we didn't do the last time, let's make sure we did this. The last time we didn't do this, you have to make sure that you identify the type of substance you have. You have a molecule, so make sure you identify that. Make sure you circle that. So on this one, we have nitrogen. Is nitrogen an ionic, molecular, diatomic, or element? So it sounds like it's either diatomic or element because it's by itself. So the way to check, if you're not familiar with your diatomics, is to go over to your diatomic list. If it's there, if it's a diatomic. If it's not a diatomic. And so you see nitrogen, so it is. So the formula for nitrogen is N2 because it is a diatomic. And so we will label it diatomic. Okay, so we're going to go in here. We're going to make sure we circle diatomic. We don't want to forget that. And then we're going to put in the formula for nitrogen. And it is N2. So we're going to make sure we put that. N2. All right. And then we'll subscript 2. And that's all you have to do. So you do have to show your work. You do have to do these example problems. I want you to do them as part of your notes. So you work them with me in the video, and you get points for doing them as well. All right. And so what you're going to do today is you're going to work on numbers 1 through 9. When you look at numbers 1 through 4, you're going to put those together in a reaction in number 5. So this is what number 5 should look like. It should look like your answer from number 1. So the equation or the formula you developed for number 1, plus the formula for number 2, arrow, formula for number 3, and formula for number 4. And so that's what you're going to show in your work there. When you get to number 9, it's going to look like your answer from number 6, or the formula you had for number 6, the formula for number 7, arrow, formula for number 8. Okay, so if you're doing these formulas right, then you're going to come up with the right equation, and you're going to be good to go. Okay, so I hope this helps, and I look forward to seeing what you have accomplished by the end of this lesson. Thank you for watching. Please do like and share. Have a great day.